On this video, I'm going to show you how to graph a parabola. All of these equations will be on this video. If the video gets too long, then I'll have to show the x cubed graph, the cubic graph, on a separate video. And I also want to talk about the negatives. Some of you were confused on the absolute value and the square root functions. So let's get started. Okay. X squared, if you just took numbers, this is your x column, this is your y column. If you just took numbers and squared them, these would be the y values you would get. Okay, hopefully that makes sense. Squaring a number makes it positive. That's why 2 squared gives you 4, as well as negative 2 squared gives you 4. Okay, so if I put those points on a graph, here they would be, and then you just draw them. I think the easiest way to draw is to start from the center, curve out. Oops, I'm doing this one-handed while I'm holding my phone, so my drawing skills are not the best. Anyways, try to hit all those points and put arrows at the end. Okay? Now, what these are going to do, like we started to see in the absolute value function and the square root function, is these numbers are just going to move the graph up and down or left and right. So, numbers at the end, move it up or down. So this would just be a down 5. That basically means I take this whole parabola and I just move it down. Okay, so start down 5. Now, these aren't going to be the actual numbers, like I'm not going to graph the point 39 on here. What it means is like 39 would be over 3 and up 9 from that first point. Okay, as well as the 1, 1, the 2, 4. Now, 0, 0 is basically your beginning point. So this is my beginning point. So I'm going to kind of ignore 0, 0 from here on out. So what this means from here, those 1s go either right 1 or left 1. So from 5, negative 5, I'm sorry, I'm going to go out 1 both ways and up 1. The 2, 4, you always start from this beginning point, okay, not from this one. So from the beginning point at down 5, go out 2 and up 4, go the other way and up 4. And then 3, 9. Give me 3, 9 if it fits on the graph. Sometimes it doesn't, but I want to see it if it does fit. So out 3 and up 9. And the other way. And one thing I like to do is you can just kind of scan across and get that other point. All right, and then make a parabola. Okay. Do get in a habit of this, right? How you're changing it. It's called a transformation. So how you're transforming it. Down, up, left, right, whatever it may be. Okay, so this one, when it's in parentheses, that moves left to right. But the weird thing is, it's the opposite of what it looks like. Plus to us would usually mean right, but it's going to go the opposite. So this is a left 3. Let me pause for a second. Okay, I had to erase my board. So left 3. So when you come down to this graph, go left 3. And then again, it's just these points off of that beginning point. So out 1 and up 1, out 2 and up 4, and out 3 and up 9. And make a parabola. Okay, I'm going to go ahead and fit this next graph on the same graph paper just because I have room and I don't want to keep pausing and erasing. So remember, this is left or right, but it's the opposite of what you'd think. So that's really going to be a right 4, and this at the end, remember, it is what it looks like. So a negative would mean down. So right 4 and down 2. I got to do both of those at the very beginning. Right 4, down 2, and then I just make my normal parabola. 1 1s, 2 4s, 3 9. I apologize in advance if I try to count this too fast because I'm trying to make this video short if I miss a point or something. All right, these next 2, notice they have a negative in front of them. So instead of the parabola being upright, it's going to be upside down on both of them. Here we're still going to figure out how we move. So opposite of that, because it's in parentheses, would be left 2, but the number at the end is what it looks like. So that is an up 7. Sorry, I'm trying to figure out where to put it. Okay, so left 2 and up 7. But then this means I'm going to go upside down. So left 2, up 7. Should be right there if I didn't try to count it too fast. And then my points, 1, 1. But I'm going down. I'm going down from the top. That should be 2, 4. And that should be 3, 9. Again, I hope I didn't count that too fast and mess up the graph. Hopefully you're getting the idea. All right, this last one, that negative, would mean that you flip it down, just like this one. Okay, I want you to get in a habit, if it says on the worksheet or the homework, to describe the transformation. That means I want you to do this. Just write up something, down something, left, right, or flip. Flip would be if there's a negative. So I should have written flip down on that one as well. So this is a flip down for that. And the 2 means all the points are going to get stretched. So you need to say stretch by 2. Okay. What stretched by 2 means is all of these, okay, remember this is your x and your y, and it's only the y values because you're stretching it vertically. All of these are going to get multiplied by 2, in fact, negative 2. So these both would be negative 2. These both would be negative 8. And this won't fit on the graph, but it would be negative 18. Okay, but notice 0 wouldn't change. 0 times anything is still 0. So we start at the center. Okay, and then we're going to go out 1 and down 2. That doesn't look like a very big stretch next, but this next set of points will be a really big stretch. Out 2 and down 8. Okay, and like I said, the 18 point won't fit. Very rarely when you stretch it will you be able to get that last point. Okay, now the last negative that I want to talk about, with parabolas is this one. Okay, do you remember actually come over here, square roots. Okay, a square root function normally is this curve like that. So if it was negative here, that means we just flip the curve down. I kind of do that well. But this one would mean we flip the curve left. Okay, so if it's in the front, it's a flip down. If it's with the x, think about that. It's basically you're going to the negative side of x. You know, on your axis, here's positive x, here's negative x. So negative x would mean it flipped left. Okay, now, on our absolute values, we know that an absolute value graph normally is this V. If it's negative, it's an upside down V. Now, if it says a negative x, that's technically flipped left, but if you think about this, you know, here's my y-axis, here's my x-axis. If I flipped this over to the left, then what is on the left has to flip over to the right. This graph is really the exact same thing as just normal, like not negative, which should make sense because an absolute value of a negative just makes the negative go away. So think about this. Those negatives makes the parabola flip upside down like I drew here. But this negative makes the parabola flip sideways like that, which basically, if a normal parabola curves, you know, so you got this part on the right and this part on the left. Sorry, I didn't draw it very well. Flipping it left would mean this side goes to this side and this side goes to this side. So it's the exact same thing as positive, which again should make sense because if you have a negative and you square it, you get a positive. Okay, the next video, I'll have the cubes on.